My name is Dr. Basitti Mallikarjuna. Today I am explaining the operating system services and user operating system interface and operating system operators. Students, last class, I explained about the what is operating system, evolution of operating systems, and how operating system can be defined. I explained last videos. Today's video, how operating system perform various services and how to interface with the user, that we will discuss in this video. An operating system is software that acts as an intermediary between the user and computer hardware. It is a program with the help of which we are able to run various applications. It is the one program that is running all the time. Every computer must have an operating system to smoothly execute other programs. The operating system coordinates the use of the hardware and application program for various users. It provides a platform for other application programs to work. The operating system is a set of special programs that run on a computer system that allows it to work properly. It controls input-output devices, execution of program, managing files, etc. So mainly, operating system is interact between user and computer. That's how it is operating system perform two major services such as command line interface and graphical user interface. Command line interface. A command line interface is a text-based interface where you can input commands that interact with the computer's operating system. The command line interface operates with the help of the default shell, which is between the operating system and the user. Second one is the graphical user interface. Graphical user interface means GUI, a computer program that enable a person to communicate with a computer through the use of symbols, visual metaphors, and pointing devices. Command line user interface interact with the computer operating system. Graphical user interface interact to the person. These are the main difference. So this is the major service of the operating system. Okay, let me see in detail about the command line interface and graphical user interface. I put two figures here. One figure is a command line interface of the left side and right side is the graphical user interface. Both are two user interfaces. It allows the user to interact with the operating system. All operating systems have user interface. So command line interface interact with the operating system through command prompt. So that is the command prompt. This command prompt, various commands are given and interact with the user. So another one is the graphical user interface. Various commands interacted to the persons. These are the graphics, how that interact with the user, such as in the graphical user interface. Okay, let them discuss what are the operating system services. Let me see one by one. First one is the program execution, input-output operations, communication between process, file management, memory management, process management, security and privacy, resource management, user interface, networking, error handling, and time management. Let's see one by one how program execution can work to the operating system. So this is a set of steps how a program can be executed. A sequence of instruction is stored in memory. Once that is the user given the system step-by-step instructions through the computer one by one. The second step is the memory address wherever the first instruction is found is copied to the instruction pointer. Step 3. The CPU sends the address with the instruction pointer to memory on the address bus. Step 4. The CPU sends a read signal to the control bus. Step 5. Memory responds by sending a copy of the state of the bits at that memory location on the data bus that the CPU then copies into the instruction register. Step 6. The instruction pointer is automatically incremented to contain the address of the next instruction in memory. The CPU executes the instruction within the instruction register. Then go to step 3. This is the inside how the program can be executed inside the process explained here step by step procedure. Then how the pictorially the program can be executed that we can see in this how the program can be execution can be seen in this picture, in this figure, the program execution. The program execution start from the source code, then given to the compiler. The compiler generates the object code. The object code given to the .exe file, then computer produces the output. This is the step-by-step instruction how the program is executing. How the source code program is executing. First, the source code is given to the compiler. Compiler execute the source code and produce the .object file, .obj file. That executing, then it produce the .exe file. Then that exe file gives the output. This is the how the program is executing in the computer as shown in the pictorial form in this figure representation. Next one is the input-output operation. First one is program execution. Then second one is the input-output operation and the communication between process. Let's see one by one. Second one is the input-output operation. Operating system manage the input-output operation and establish the communication between the user and device drivers. Device drivers are software that is associated with the hardware that is being managed by the operating system so that the synchronous between the devices works properly. It also provides access to the input-output devices to a program when needed. Next, communication between processes. The operating system manages the communication between processes. Communication between processes includes data transfer among them. If the processes are not on the same computer but connected through a computer network, then also their communication is managed by the operating system itself. So this is a communication between process. Next one is the file management. The operating system helps in managing files also. If a program needs access to a file, it is the operating system that grants access. These permissions include read-only, read-write, etc. It also provides a platform for the user to create and delete files. The operating system is responsible for making decisions regarding the storage of all types of data or files, that is floppy disk, hard disk or pen drive, etc. The operating system decides how the data should be manipulated and stored. This is a file management. Next, security and privacy. Operating system keeps our computer safe from an unauthorized users by adding security layer to it. Basically, security is nothing but just a layer of protection which protects computer from bad guys like viruses and hackers. So operating system provides us defines like firewalls and antivirus software and ensures good safety of computer and personal information. Next, privacy. Operating system gives us facility to keep our essential information hidden, like having a lock on our door where only you can enter and other are not allowed. Basically, it respects our secrets and provide us facility to keep it safe. This is security and privacy. Then memory management. Let's understand memory management by operating system in simple way. Imagine a cricket team with limited number of players. The team manager decides whether upcoming player will be playing 11, playing 15 or will not be included in team. Based on his performance, in the same way, operating system first check whether the upcoming program is fulfill all requirement to get memory space or not. If all things are good, it checks how much memory space will be sufficient for program and then load the program into memory at a certain location. And thus, it prevents program from using unnecessary memory. Next, process management. Let's understand the process management in a unique way. Imagine our kitchen stove as CPU where all cooking execution is really happen, and chef as the operating system who uses kitchen stove CPU to cook different dishes as a program. The chef operating system has to cook different dishes program, so he ensures that any particular dish does not take long time, unnecessary time, and all dishes programs get a chance to cook. Cooking means execution. The chef of operating system basically schedule time for all dishes as programs to run kitchen on all system smoothly, and thus cooked means executed all the different dishes means programs efficiently. System resource management comes under a resource management. System resources are shared between various processes. It is the operating system that manages resource sharing. It also manages the CPU time among process using CPU scheduling algorithms. It also helps in memory management of the system. It also controls input-output devices. The operating system also ensures the proper use of all the resources available by deciding which resource to be used by whom. Next, user interface. User interface is essentially and all operating system provide it. Users either interacts with the operating system through the command line user interface or graphical user interface that we discussed at beginning itself. The command interpreter executes the next user specified command. A graphical user interface offers to the user a mouse-based window and menu system as an interface. Networking. This service enables communication between devices on a network, such as connecting to the internet, sending and receiving data packets, and managing network connections. This is one of the major service networking. Next, error handling. The operating system also handles the errors occurring in the CPU. In input-output devices, etc., it also ensures that an error does not occur frequently and fixes the errors. It also prevents the process from coming to a deadlock. It also looks for any type of error or bugs that can occur while any task. The well-secured operating system sometimes also acts as a countermeasure for preventing any sort of breach of the computer system from any external source and probably handling them. Next, time management. Imagine the traffic light as an operating system which indicates all the cars or programs whether it should be stop, red color, it goes to the queue, stop and go to the queue. Start means yellow color, start yellow gives rise to ready queue. So move, if green color comes, move operation, move green under execution. And this light control changes after certain interval of time at each side of the road computer system so that the cars are as a program from all sides of road move smoothly or without traffic. This is time management. Yes, this we see so far various services like program execution, time management, resource management, process management, memory management. We've seen all these things as services of operating system. But a computer system architecture is has input devices, keyboard, mouse, other input and output devices are connecting to the CPU as a memory. The memory processes the data and information and produce the output. Output devices are monitor, printer, speaker, and other output devices. So I given here the top leftmost diagram is a computer system architecture. These are input devices of the left side, and these are on right side. These are the output devices. In center there is CPU and memory. How the information is as processing. So this is a computer system. Computer system architecture means the inside the computer system how that performing the various services. The services all are handled by the input devices and output devices of the computer, and process the data and information in the as a services of the computer. So in the computer system architecture, there it may be a present days, it may be a laptop, it may be a mobile, it may be a computer, or it may be communication among various sources of the computer. All computers, either it may be laptop or it may be computer or it may be mobile phone. All we discussed services, all performed by all devices like computer, mobile phone, laptop. But how the services can perform means the information. The information here, this is a folder, like a folder. The information is stored in the folder. So these are the images I taken from the source as given here. This is the image. So images I collected from the source. So we discussed the various services of the operating system and interacted with the user. That's why operating system services, user operating system interface. That's we're discussing so far. Coming to the operating system is a resource allocation as a figure here. Error detection and error occurs due to this. This is the figure. This is the figure once detecting the errors. So error detection is also one of the primary service of the operating system. If there is error, it detects it. The errors comes to the printer also. Sometimes printer not working. That time we will check the troubleshooting. So the printer once you rectify the troubleshooting, after that the printer starts working. But how this is working? One of the service as a resource allocation. How the resource allocation can be represented, the figure resource allocation graph. This is a resource allocation graph as represented here. There are the resources are R1 and R2 resources as the rectangular box as the resources. The circle boxes are a process. This P1 is a circle box, process P1, process P2 and process P3. All processes are communicating to the resources. The arrow from resource to process shows that this is the arrow from resource to process shows that process P1 is holding R1. Again, resource R2 shows that process P2 is holding resource R2. In process P3 is waiting for resource R1. Process P3 is waiting for resource R2. A arrow from process to resource is nothing but a waiting stage. So process to resource arrow is a waiting stage. A arrow from resource to process is nothing but holding stage. A circle from resource to process is a holding stage. This graph can be represented as a resource allocation graph. This graph is a resource allocation graph. So resource allocation graph is very important. In coming videos, I explained in detail about the resource allocation graph. Why? Because the resource allocation is one of the primary service of the operating system. Okay. Then coming to the operations of the operating system. Operating system operations, there are 4 major operations: process management, memory management, device management, and file management. And this is the diagram of the figure. Operating system operations is a center, and all process management are connecting to the process management, memory management, file management, and device management. Let me check one of the primary operation as the process management. The operating system is responsible for managing the process, that is assigning the processor to process at a time. This is known as process scheduling. The different algorithms used for process scheduling are first come first served, shortest job first, priority scheduling, round robin scheduling. This is the process management. Next, one of the primary operation is the memory management. process of regulating computer memory and using the optimization techniques to enhance overall system performance is called memory management. Memory management plays an important part in operating system. The activities performed by the operating system for memory management are the operating system assigns memory to the process as required. This can be done using best fit, first fit, and worst fit algorithms. All the memory is tracked by the operating system. This is memory management. Next, device management. This is one of the primary operating system operation. The process of implementation, operation, and maintenance of a device by operating system is called device management. There are many input-output devices handled by the operating system, such as mouse, keyboard, disk driver, etc. There are different device drivers that can be connected to the operating system to handle a specific device. The device controller is an interface between the device and the device driver. The user applications can access all the input-output devices using the device drivers, which are device specific codes. Next, finally, file management. Managing the file system to enable users to keep their data safely and correctly is an important function of the operating system. Managing file system by operating system is called file management. File management provides tool for these file related activities. Creating new files for storing data, updating files, sharing files, securing data through passwords and encryption, recovery in case of system failure. Okay, in this video, I explained the various operating system services like process management, resource management, file management, device management of various operating system operations. Also, we've seen, but also the primary service as the process execution, program execution, and then resource management, file management. That all various services we've seen here in this video. So I collected from the material from the resource of the video for the references of two books, Abraham Silberscrabge and William Stallings. These books are references are given here. Okay, students, I explained in this video of the operating system services and operating system operations. Thank you, students.
Like, share and subscribe. Hit the bell icon for more updates.